Welcome back. We're starting at number 7 this time. So, according to a new survey, in 2010, pet ownership in the U.S. was distributed as shown in the table below. This is out of 1,000 households, so you know that your total here is 1,000. Please read the problems in these. I get a number of questions asking me, well, how do I know what the total amount of people is? Do I have to add up everything in the cells? Usually they'll give it to you in the very beginning of the wording of the problem and the question. So, probability of having no pets, pretty simple, adding up all of the column with no pets, taking it out of 1,000. Probability of having a pet, that's everybody else. So again, 1 minus 22.2, that's signaling 100% minus 22.2%. So everybody else, 77.8% of people would have pets. I'm included in that. Isn't that right, Randy? He's not a talker today. Person selected at random. What is the probability the person earns under $35,000 and owns a dog? So under 1,000 and owning a dog, that's only these two cells of people. Here's under 20,000 owns a dog, 20,000 to 999. It's these 66 people, so that's 130 out of the 1,000 people total. Probability that the person earns under 35,000 or earns a dog. A couple ways you could do this. First one, of course, is adding up all the individual cells. So you could add all of these together. Everybody that's under 35,000, also everybody that owns a dog. So all of these 5 cells, including all of these 10, you'd have to add together. You get 641 out of 1,000. And then for part E, using another method, you could do this by finding the probability that somebody earns under 35,000, which is 385 out of 1,000. The probability of somebody owning a dog, which is 386 out of 1,000. You could add those together, but you have to subtract your overlap, because when you do that, you double count these two people, right? This is all the under 35,000. This is all the people that own a dog, and so we just counted 64 and 66 twice, so you have to subtract a 130 out of 1,000 to get 641 again. F is another conditional probability problem that a randomly selected person who earns under 35,000 owns a dog. Is the probability they own a dog given that they earn less than 35,000. So the people earning less than 35,000, that's your new sample space. That's 385. That's all of these people. Right, that's your new denominator. And then the 130 people that own a dog are on the top again, so 33.8%. 8 is another problem, just like the very first problem on this review guide, taking BE times EC equals AE times ED, setting it up in an equation like this and solving for X. Flipping. Get cooking. A big warehouse carrying tents has a miniature model that is similar to the full-size tent. The tent is triangular base prism, and the miniature model has dimensions shown in the diagram. So how much fabric does the tent use? Again, that is surface area. So finding the area of all of these surfaces, we have 2 triangles and 3 rectangles. So in the back here, this one on the front and on the bottom. So that's what these are all finding. You end up with 30.96. A little tricky, you will have to use Pythagorean theorem to find that slanted part. 3 is the height, 2 is the base, so you end up with this right triangle of 1, 3, and I'll call that C. So you'd have to use Pythagorean theorem. A squared plus B squared equals C squared. Part B, volume of the small model. So just taking, it's a little weird, the area of the base. The base, again, in this case, is this triangle. The base is not always what is on the ground. It is what is attached to another of its kind. All right, so you see these 2 triangles are attached to each other with some lines. That makes them the base. The base cannot be this rectangle because it goes up and meets at this line. Like, it would have to meet with another rectangle. So area of that triangle ends up being 3. 3 times 3, that's the height. I know it's like on the ground, but it is the height. End up with 9 feet. If the volume is 72 feet cubed, how tall is the full-size tent? So this goes all the way back to our scale factor talk. And if your scale factor is R, your area scale factor is R squared, your volume scale factor is R cubed. So if we know that R cubed is 8, right, the difference in our volumes, then we sort of have to go backwards to find out what the regular scale factor is, because that's how the height is going to be determined. So to do that, you're finding the cube root of 8, which is 2. Taking 2 times 3 will give you 6. Right? 2 times your original height, which was 3, to get the height of the full-size tent, which is then 6 feet. Part D, how much fabric does the full-size tent use? Go back again to this scale factor talk. So if the scale factor is 2, area must be increasing by 2 squared. So you can take your original area from up here, take it down, multiply it by 2 squared this time because it is area 123.84. Now this problem has come up before. It's come up in I believe a review guide and on a test. So I'm not going to spend a whole lot of time on it. It's a more conditional probability though. A student is an engineering major. Given they're an engineering major, what's the probability they live on campus? So the 920 is all the engineering majors. That's your new sample space. 120 is the engineering majors who also live on campus. Independents, follow this formula. So probability of A given B equals the probability of A. You can also do this by saying if the probability of A and B equals the probability of A times the probability of B, then these are independent, so therefore they would be not associated. Independent things are not associated, so since these do not equal each other, they are associated. And they're not independent, they are associated. Number 11, annual homecoming parade. 3 students get to ride the lead float. 7 are being considered for the coveted position. How many ways can 3 students be chosen for this honor? So first think, does order matter? And I would say no, because it's just people riding on the float. Nothing like nobody's in a certain position, nobody's first, second, or third, anything like that. But you have 7 people, and you are choosing 3 of them. Again, you can do this on a calculator. So if you're following along on a graphing calculator, you're pressing math. You're scrolling over to PRB, and then you're going down to number 2 and number 3. Both of those, number 2 is your NPR, number 3 is your NCR. So if you want to use those on a test on a calculator, you can. I went around and showed everybody that one day. But you can use this, so you just have to type in 7, type in NCR, and then type in 3 on your calculator, and it will give you 35. Just spit